have a handful of people in here. Good evening once again. My name is Ginny Manuel Kalu is my name, and I'll be your host for today. I'll be your host for today. So to start with, okay, I want to record this class. Okay, so that we can be able to refer back. All right. So now this is Orion 18. If you've installed your file, some people chatted me up and was like, if we can start from basics. Yes, we'll give a background basics and we'll model from basics. Then we'll enter into the master class properly. And because of this, we'll see if we can practically push our class a day forward, because of it's a way of me saying I'm very, very sorry for the delay for today. So now, when you have this, the first thing to do on how to open Orion 18 is that you go to the icon on your desktop, or you go to your Windows. You go to your Windows. So if you go to your Windows, you can get the icon here, double click on it, and the app opens. So you wait for it to start up. Now, when it starts up, you can actually close. You can actually close this. This is the now this comes up. With this system, these are just a couple of toolworks I've done with this system, and so as many works as you do, they keep coming up within this this place. So now this is like your what's it called? This is your project directory. This is where you see your projects. So but the main directory in your system will be located in the documents under public. That is where the main document will be directory is located. So when you open this, the next thing you will see is a new project. You see project manager, you see delete project, help, you see okay, exist, and now filter talks about Orion 17, Orion 15, leave it at all versions, leave it as it is, like this now. And so now to start with, you just have to click new project. Now it brings up the project code. So this project code talks about the title of your project. So I can call this class, I can call this master class. Mind you, spacebar does not work here. So I'm gonna call this master class. So I'm gonna use shift/_ So I'm gonna use shift. I will press underscore and it will come up. I'm gonna call this master class 1 or day 1. So I'm gonna use this master class day 1. So I'll click OK. Now, at this point, I have to select the code I want to work with. We have Ireland code on Euro code, Malaysia BS 8110, and you see a whole lot of code, Singapore, Malaysia Euro code. So here in our country, in Nigeria here, we use BS 8110 and UK Euro code. So it depends on what you want to use. For me, I'm going to use 8110, BS 8110, and not Euro code. So I'll click on import. So the page comes up. It's telling me now to set my page. So it's telling me standard sheet is you see A4, A3, A1, A0, or whatever. So here I actually want to use this X 15 by 1000 millimeter. So you see your A3, A4. So you can actually use A3 paper size or A4 paper size. And the UCI will automatically be crafted to A4 paper size. So, but I want to use this for bigger projects. And so I'm gonna select that. You leave the width, automatically it's telling you the width is 15 by 1000. And so you can pick your origin if you want, but the drawing scale is 1:150, and the detail scale is 1:20. So now this is the deal. You know, most times people detail with Orion 18, and they would run design with Orion 18, and they got to find out their details is very small. So when they go to AutoCAD, they have to start scaling it up. They have to start scaling it up. So now, for you to understand that, you want your drawing to be bigger, you want your details to be bigger, you can actually increase this from scale 20. You can take it up. So you know the rule now. The bigger the scale, the smaller the drawing. The higher the scale, the smaller the drawing. So if I have a drawing at scale 100 and a drawing at scale 75, 1:75 is not the same thing. It is the same dimension, but the scale is different. Do you get? So now this is just about the scale of the drawing. So your detail is to scale 1:20, 1:20. So I can take my details to scale 1:15 to make it bigger. Now my drawing scale, I can bring it down to scale 1:45. Remember, we are trying to break everything down. We're trying to break everything down. So at this point, having said this, I can click OK. So it will take me to the UCI where this thing is. And now having this here now, having gotten this to this point, the next thing now is let me bring down this so that you'll be able to see me clearly. Okay. So now the next thing now is where do we start from? How do we model? Now there are two methods of drawing in Orion 18. You can actually import your drawing from the architectural drawing that was given to you. You can import it into this place and you save as. So you can import it and you save as. Now, apart from importing, by tomorrow, we're going to be dealing with importing of architectural drawings into Orion 18. But today, I'm going to show you another means whereby you can actually sketch inside Orion 18, whereby you can actually want to sketch inside Orion 18. Now, let me give you a brief background of the ribbons that we have here. So under the file, before that, let me give you a brief background. We have under the file, we have new, open, open previous backups, save projects as, you want to rename the project name. That is where you use save as. Archive a particular project, load project from archive. So when you load this particular project now to archive, you can actually pick it up later on. You can actually pick it up later on. So we have file model import, file model import. So under this file model import, we have a load building model. We have external reference drawing, and we have import from Revit. Now, when you are loading building model, when you're using load building model, for people that uses SketchUp, when an architect gives you a soft copy of his drawing, a SketchUp soft copy, so that is where you can use this load building model. So another part is external reference drawing. Now, this external reference drawing is the part from AutoCAD. So an architect gives you a drawing from AutoCAD. How do you import it? This is through this external reference drawing. So I will show you how to add it under external reference drawing, probably by tomorrow. And now the next other part is import from Revit structure. So someone models a drawing in a Revit architecture. So he pushes it to Revit structure. Or maybe you've used Revit structure to design. Do you get? There are a whole lot of structural softwares, and Revit have Revit structures for structural software, and it's also one of the good softwares, though it's a bit technical. It requires a whole lot of tenacity. So to import from Revit structures, you have to click on this. Now, this model exports. Now, when Orion, after modeling, when Orion wants to export, give you back what he has given, he generated, he's giving you, the software gives that to you in two areas. It gives back on DXF exports. That is, if you're conversant with AutoCAD, you should know DXF export is another what do I call it? Is another save as link, whereby you have DWG, template, DXF, standard, if I'm not mistaken. Or if I open my AutoCAD, we'll get the other parts of AutoCAD. Probably we'll deal with that tomorrow alongside. Then it can also export to Revit structures. So these are the two parts. So you don't use what's it called? You don't use SketchUp and expect it to give it back to SketchUp. It won't. Orion will only give you back in AutoCAD and in Revit structures. So now you want to link a model. Now this model, this linked model, has to do with I've modeled something in SketchUp. So I want to link these two models. Do you get the thing now? So I want to link these two models. I've done that. I imported it. So if I want to link another model, this particular model to another model, let's say you have two big projects and you want to join two of them up and see how the analysis is going to be, how the whole structure is going to react when you run analysis, you can use Link Model Manager. So we'll get to that. Then the other one is Plot. The other one is Report Manager, Orthogonal Axis Generator. I will explain that. Quantity extraction tables and project properties. Now, quantity extraction tables talk about, we want to get, you've carefully modeled your design and the extract is what you like the reinforcements, you like everything. So you want to get the volume of concrete, you want to get the quantity of reinforcement. This is where you actually get such. This is where you actually get such. So now we'll go to edit, you see move member and all that, select entity, clear selection, you know, this fancy fence selection and then entity selection, you know, if you're using AutoCAD, you should know when you take from the left to the right, is called window selection. And when you select from the right to the left, from the left to the right, it's called window selection. From the right to the left, it's called fence selection in AutoCAD. So, all right. Now, that is it about edit. Under a view, you want to zoom. I won't dwell much here. It's self-explanatory. So visual interrogation talks about the colors of the details in your eyes. Visual interrogation, you want to, you know, work on your the visuals. You want to work on the visuals. So you can actually, if you click on it, it will take you like, it's just like it's telling you now, presently now we don't have any shading, we don't have any columns or one other loads. So you can actually, when you're working on it, we'll get back to this when we start modeling. Then under here, we'll have building parameter, generate story, delete story, remove story, edit story. And under members, we have peak, axis, column, wall, beam, slab. So this is what I want you to do. I want you to note these icons, note the icons, because these same icons, they are the ones here. They are the ones, this is your building icon within here. This is your building icon. So if you check, sorry, your member icon, you see peak, axis, and you see member selection, type definition, and all those things. So I'm trying to explain all of them because of the, what's it called? The fresh ones, the people that have used it for a very long time. so that by the time we go into it, we can dissect any of these. So I also want to put up, please, if you're in the group and you have any drawing that you want us to, work on, use for the class, you can send the AutoCAD file. Please do not send PDF. We will not be able to convert it. You can send the AutoCAD file. We'll open it here and we'll work on it live and direct with you. And so now, under run, we have load decomposition, finite element load decomposition, building analysis, finite element flow analysis, column section design, beam section design and detailing. So we have story beams, you have your rib beams, you have your foundation beams. So when you're adding a beam, Orion sees it in 3 categories: foundation beams, rib beams, and story beams. So rib beams talk about when you're having a rib slab. So we'll work on rib slab here, we'll work on waffle slab, and we'll see how far we'll go. So the foundation beams talks about, let's say I want to do a raft foundation, and it's a raft beam that I want to use or that I'm using. So the raft beam that I'm using, it will be seen it as beam foundation. Let's even say I want to do a stripe foundation. You have to put up, it will see the beam there in the foundation area as foundation beam. So we have slab analysis and design, rib slab analysis, stair design. Now, let me show you, this is one little challenge Orion have. The challenge Orion have in stair design, it doesn't give you details, of the staircase. But with the little thing it will provide, you can actually run your detailing and your design properly. You can see it will give you a little breakdown, but other ones it's perfect in it. So we have column punching check. You want to do your punching check analysis check, you can do it here. So under settings, we have setting and parameter manager. We have general settings. So under general setting, let me be opening them. So you see general, the grip size is medium. You can, if you select large, you see what it will come up. The O snap is small, yes. The selection box is small. The screen font is this. So the font at which you're going to be using for this, for Orion uses, is MS Sans Serif. So if you don't like that font, some people after going to AutoCAD, they'll start changing the font. You can change that there. So I can decide I want to use David. I can decide I want to use David. Okay, I'm coming. I can decide I want to use a particular, let me say David. Okay, so okay, look at this one. It has gone off. I'll keep doing D. It will come back. This is David. The other one I was looking for was good. I can decide I want to use this DF Chi SB. And the screen font size I want to use is 9. I will have the highest here as 10. So I can use 10. So let's say you have for our leaders who have little eye problem and you want to make the text bigger, even in Orion, you can do that here. Do you get it? So the story label prefix. So it's your Orion labels at ST. So I can decide to call this FL. I can decide to call this, it's not editing, okay. Okay, it's a general project base. This one is on the general project base, so you cannot edit this. So the animation, or you are going to see it, or when you model, you can see the animation. If you want it that folded on or that, maybe probably when we are modeling, you understand this properly. So under view now, angle step, I don't actually advise because you distort your Orion for you to venture into display icon and display type member type. When you say display icon, display member type, you start on checking them, and most people will start having issues. So they will not be able to, come in, get back to this point and re-edit them. So I'll go to save. You see, Orion on his own do automatic save at 10 minutes intervals. 10 minutes intervals. So number of backups is 3. So card editor is using your default card editor. So let's say now I have, for instance, now in my system, let me show you something. Okay, in my system, I have AutoCAD 27, 2016, and I have 2018. So if I have these two AutoCAD, these 3 AutoCADs, the one that is my basics is 27. That was the one I made my basics. So that if I'm sending a soft copy of a work, maybe to my mentor or to my leaders, if they have the lower version of AutoCAD, they can open it. If you also have the highest version, you're good. So now someone may be asking, how do you save such? So let me load this AutoCAD. I'll show you how to save that. But let's go back to Orion while AutoCAD is opening. So the company name. So let's say now I might be doing a design and with someone's system, and the company name is not the one I work with or the one I work for. So I'll just come here, edit the company name, put in my own company name, or the company name that has the design, and click OK. So when I click OK, now that is it about the settings, the window, how to, it will have plan view only, you'll have it cascade, you'll have title horizontal, tile horizontal, tile vertical, you want it to window, and we'll go into this virtually. So, but you notice all those things that were both in member, in run, you see that, look at them here. Now, these ones are the story, this one is drawing sheet set, this one is a parameter. So having done that, okay, I think my AutoCAD is up. All right, now let me show you how to save on, have a default card saving. So I'm gonna right click, I'm going to go to option. I just want to show you something here. We'll go back to Orion. I pray this doesn't take our time. Okay, so you see file, display, open and save. So I'll click open and save. You see save as. I'll click, you see, I have 27 AutoCAD. So I can still come back and say 2018 DWG. I can, what I'm having is 2018 so AutoCAD. This is 2018 DXF. This is template that I was telling you about. This is DWG 2724. So if I scroll up, I'll see 2018. So if I save it, automatically I'm making mine and go back to 27 and do that automatically, or 216 and do that automatically. I'm telling the software that my basic saver, when I do when I save a work, should be 2018. So automatically this is still in 217. So once you select that in 27, once you select that, you say apply and click OK. Your work is in 218, is in 27. So you have that as your basics. So you don't need to move on and on with that. So, okay. Now let's start off with a model. Let's start off with a model and see how far we go. So like I told you, I want to show you how to model from scratch. So I'll click on File. I'll click on Orthogonal Axis Generator. So when I click on it, it seems as if nothing happened. Do you get it? So I'm going to click here. When I click inside this environment, design environment, a pop-up a dialog box comes up carrying the Orthogonal Axis Generator. Orthogonal Axis Generator. So now look at this. We have reference point as this. Forget about the reference point, insertion angle, the label A and 1. So if I want here to be 1, I'll make here A. Do you get it? Direction 1 and direction 2. So I'm going to say extension by length. Make it 3 meters, 3,000. Extension by length is 2 meters. So I want to make it 3,000. So now, having done that, the next other thing will be the axis spacing. So I'll click on axis spacing. I'll say I want it 3.6, 3,600, 4,500, comma, let me say 3.0, no, 3000. Sorry, this is in millimeter, comma, let me say 5 meters. So this is what is going on the x-axis. So I can come on the other axis, on the y-axis, and say, okay, I want this 4 meter. So the first block is 4 meter by 3.6. The next one, 4,500, or 3,000, 3,000, 3,000, 5 meters. So having done this, I'll click OK. So automatically you see this is what we sketched. So this is what we sketched. So I can use dimension. This is section, this is dimension. I can click on dimension and click on this and click on this and bring it up. So I did not get the exact point correctly. Click on this and on this. What's the problem? Probably I'm not getting the insertion points. All right, I was just trying to see if this will, correspond and show me give me the dimension of what I'm looking for. All right, this is, oh, sorry, this is 3.3. So probably this is the 3.6 area. I'm trying to get it exactly, is not coming up. 3,120. So you just click, you see, it's 3.6. It's just 3.6. So I can click on this and click on this. I did not get it right. I can click on this and click on this. You see, this is the 4438. Probably we didn't get the insertion point of 1. You see, this one is a bit far. It's not close. So this is the 4.5 area. Do you get? So now, having this, if we have this now, the next thing is I want to place my columns. I want to place my columns, and please, if you have question, it's good to know if you're catching up. If you have question, kindly pop it up on the chat. Type it up on the chat. I will respond immediately to that. So I'm gonna select a column. So today I'm gonna do a normal, maybe an open area design. Let me use that word. So now this is the dialog box. Okay. We have a question here. Who is that? Okay, someone said, can you please run through the axis again? Okay, you want us to rerun the axis again? No problem. We'll do that. We'll do that. I'm going to select this and right click and say delete. I say delete axis and dimension. I say yes. So we want to show that again. So you go to file, orthogonal axis generator. You look at this now, orthogonal axis generator. So I click on orthogonal axis generator. I'll click inside here. This one comes up. Remember, I made this extension by 3 meters, and I made this extension by 3 meters. That is to say, after the first point, the offset is just like when you're doing a setting out of building. The offset, you have that 1 meter offset when you're doing your pole line. Is it pole line? I hope I got the correct engineering word. So the offset that you have there is 3 meters. Just get the word offset. I'll get the exact word, and maybe when we get there, we'll explain. So now here I'm going to use 4,500, let me say 3,000, let's say 2,000, Okay, let's use 3 span. So this other one, I want to use 3 span again, 4,000. So let's say it's 4.5 by 5 meters, 4 meters, let's say 3 meters. So I'll click OK. So I have this. So you see now, here is 1, 2, 3. Here is ABC. Do you get? So now, from here to here is the 3 meters offset I was talking about. Do you get it? So from here now, from here to this point is the 3 meter offset. I don't know if we'll get it clear. Engineer Lade, I hope I got the name. Okay, Olaseyemi, I hope I got it clear. I hope you've gotten it. All right. So let's move on. Okay, now this is column. This is the column. I'll select this. A dialog box pops up. So, you know, just like you arbitrarily select your column size in a building design, you select for your L1, L2, or your B1, B2, or whatever, you know, whether 225 by 225 or 225 by 450, whichever area you want to select, you want to use, parameter you want to use for your design, you just include it. So we're doing a very short building. So I'm going to do 225 by 225. So eccentricity, E1 means the center. So I'm going to say 112.5, which is half of 225. I'm going to use 112.5 also. So I'll go to model. I'll select default 2025, still 410. You can design our boss, Onyenoga, used to design with arrow 10. You know, with the situation of things in Nigeria now, the Nigerian factor in steel, I don't know, I was doing a steel test few days ago, and I got to find out the one would call for 10. What I was getting was 300. We have to push off that reinforcement and get another one. Now we use these for bridge we're doing here in the Boeing. We use TMT that should be giving you at least 500, and we're getting 48. So where we had like 1 bar, let's say 4 bars, we have to make it extra 1, reduce the spacing and make it extra 1. Why? Because we're looking at the strength of the reinforcement that was provided. Because when you're calculating, your software and your manual is telling you 410 reinforcement times 4. So it's already carrying that 410 FY steel strength for 4 bars. And what you're buying and using in your project is around 300, 380 at most. If you're very lucky, 390. I'm not sure. I've not seen 400. I've not seen 400 for a very long time. So you can use 250. So you can use 250, and also to run your design is also advisable. You can run a check. It's a very simple software. It's not as difficult like Star Pro, SAP, and all that. You have to undergo a whole lot of stress. So you can run again as many times as possible before you can now say, okay, for 250, 410. So when you run with 250 and it's giving you 5 bars, it's not okay comfortably. If you give 3 bars, or even say the 5 bar and give it 410, you're safe. Okay, so so you go to drop, nothing is there. We're not going there. Here it talks about the column drop panel. I don't know how to, I don't have images to explain this column drop. But I will advise you can read up on column drop. It's just like a little plate that is attached to the column. So maybe you want your column drop. You want to have a column drop, a kind of a plate like, and you can insert it. But for this simple structure, maybe tomorrow we use the column drop panel, and you see how it goes and all that. So I'll come and click here. I want, these are the shapes you can have. Not actually shapes. These are area of positioning, ways of positioning. If I select these now, my eccentricity changes. If I select this, my eccentricity changes. So you can, even without imputing your eccentricity, and just be selecting this one, and it will be giving you the eccentricity. You see this one? So now this is column end conditions. Look at here. This is your column end condition. So if you don't know about column end condition, just kukuma leave it. Just kukuma leave the column end condition. The software will use its hand and decide. But as an engineer, you can know, okay, whether the column is fixed or not. So these are the two edge conditions of your column. You have the top and you have your bottom. So this is the one. You can actually remove one and put one. You can actually remove this and remove this entirely. Do you get? So if you don't understand about this, the column end conditions, I'll advise you can read up on that. There is a whole lot you will have to dissect in this class. So, but I'm going to click on updates. I will go to the intersections and put insert the positions where I want my columns to be. I will insert them. So I'll carefully go to the intersections and insert them. And I'm going to carefully insert this. And so there is no rule in inserting your not too much rule. The only rule is it must come in between an intersection of one or two axes. So I'm gonna click on these two, and probably I want to try something a bit funny here without the column. I want to try some. This is a master class, so I try funny things a bit though. So I want to leave this span without a column. Let's see how critical it will be, and let's see how let's see how critical it will be though. So now I'm gonna close this. Having inserted my columns, but now look, I want to do something a bit. I want to show you something a bit. If you select this, your axis, and right click, you can check the properties, you can offset, you can move, you can stretch these axes. You can stretch to member intersection, extend, and all that. You can delete and mirror and all that. So, but let's try one. So I want to offset. I'll select, click offset. Offset from previous distance. What's the distance you want to offset? I want to offset. Let's say I want to have a cantilever of 1.2. So I'll click here. I'll hold Control to make it straight. I'll drop. You see now, so I have this. So I can close this and select this axis again, right click, and say offset. And I can say, since it's the same 1.2 I want to use, I can move. So I will click OK. I'll close this. But now let's use this and practice move. So I can right click and say move. It will ask me to which distance. Is it 1.2? Let me say yes, 1.2 to make it 2.4 meter cantilever. Will drop. So you see from here automatically, from here to here is 2.4. So now, having done that, let's use the stretch tool here. So I'll select this, I'll right click and use the stretch axis, and I will click, I'll stretch. I'll select this, right click, stretch axis, click, hold Control if you see it's not straight, and drop. And stretch axis, right click, stretch. And so now I want to try one of the two. Stretch to member intersections. If I click to stretch to member intersection, it's asking axis extension is 2 meters. Consider as well, shrink axis intersection as well. Okay, now it's going to go back. Apply to selected axis only. Let's say if I click OK, so it's going to move back. You see, it moved back from the position it was. It moved back. So I don't want that. I'll do Control Z, And you see, so, but now, okay, let me select this and stretch axis again and drop. So I'm going to select this on cool and stretch axis and drop. So, but you notice my stretching, we are not actually at the same point. But I want to show you that you can actually stretch your axis. So at this point now, I want to insert my beams. At this point, I want to insert my beams. So after this point, I will tell us to go and rest, practice. For those that are beginners, that is why I'm cutting. I'm going to cut the class a little bit. So go and rest, practice what we have. If you don't have the Orion, please chat up on the link on the WhatsApp group so that we can forward the one we've been able to forward to some people on their mail. So that we can forward to you alongside, maybe share the link with you. And once you get it, you will, once you get it, you can download from there. We sent it via WeShare. So you can use either WeShare app or you can use just the normal browser and download it. So, but now let's go back to where we stopped. So this is our beam. So I'm going to select the beam and B1, B2 talks about the breadth of your beam. So is it a wide beam or is it a normal 225 beam? Is it a 450 beam? Is it a 600 beam? So you have to decide. So let's say I'm using 225 first. Then the bottom I'm using 450. And so if you check this is insertion. Do you get? Just like when we were talking about eccentricity in columns. So if you want it to be in the middle, you just click here, select this. You want it to push out the other side, you can select this. Want it to push in, you can select this. Do you get the gist now? All right, so this is it. So I'll go back to model and I'll select concrete, 2025 grades, 20 grades of concrete. Still, I'll select 410. I'll say update. Now, before I click on update, you see the beam end conditions. So as an engineer, you cannot, end conditions is very, very important. End conditions is very, very important. Maybe probably if we don't have a work that we are working on, I'll bring up one of my work where we are having 6-meter columns spacing, 6-meter column spacing. And there's one that we are having about 10-meter column spacing. So it's the only way you can tackle the beam is by end condition. Is by end condition. Is by end condition. That's the truth about it. So I'll say update, and I'll select from here to here. I'll select from here to here. I'll select from here to here. And I'll select from here to here. So I have this crossing. I can decide, because there is no, because of the span, I can decide to make this by 600 and say, I don't want to click update. Now, this is the thing. Once you click on update, this is what that will happen. The last beam will update to 600 millimeter depth. Let's try it out so that you see it. I'll click on update. Look at this, 600 millimeter. Do you get the gist now? So instead of doing updates, I'm going to delete that beam and go back to 450 and say update and reschedule, re-input it. So instead of doing update, when I put 600, I'll just go ahead and put my beam 600. Automatically 600. Do you get the gist now? So now, here is cantilever. I can also decide to pick from here to here and pick from here to here. So I want to pick another cantilever. I want to pick from here to here. So you see now this beam started with 600, 450, 450, 450. So I can pick from here to this point. So I have 600 also. So probably you want to put a beam here. If you want, you can put up a beam. For here, I don't want to put up any beam. So I'll just drag this uncle to this point. And so this is how I want the shape of the building to look like. Is how I want the shape of the building to look like. Now, in this, we are not considering staircase. We are not considering staircase. So now, before I call it off, let me give you some of my necessary assumptions. So in this assumption, I'm going to use my slab as equals to 150 millimeter. And that's next. Then the next one, I'm going to use my unit weight of concrete. Unit weight of concrete, I'm going to use unit weight of concrete as 24 kilonewton. So the floor finishes, I'm going to assume use 1.2 kilonewton. I'm going to use 1.2 kilonewton. So since what I'm doing is a residential building, I'm also going to use 1.5 kilonewton for imposed load. So you will see where we'll be putting these things inside Orion for imposed load. But I want you to take note of this for our imposed load. So I'm going to be using 1.5 kilonewton per meter square. It's important to use the distance very well. Sorry, per meter squared. So I'm using that 1.5. So this also is per meter squared. The 24 kilonewton is not per meter squared. So now, I'm going to go down a bit. Let me show you about, okay, let's calculate our load. So we already know that our W is equals to 1.4 GK plus 1.6 QK. We are conversant with this. So you want to generate your W, 1.4 of your dead load plus 1.6 of your life load. So so let's get this. Let's get it up. So I'm going to say, okay, my GK, what is my GK? What's my dead load? I'm going to say 0.515 multiplied by 24 equals to 3.60. So I'm going to say finishes. Remember we said our finishes, we have said allow 1.20. So in that note, the next other thing is my partition allowance. My partition allowance is gonna be equals to 1.50. So if you calculate this is 3.60 plus, let me use calculator here so that calculator. Okay, let me get calculator. So this is it. So we'll have 3.60 plus 1.20 plus 1.50. equals to, so we have 6.3. So we're having 6.3. So we'll come back here. We'll say our GK equals to 6.3 kilonewton, 6.3 kilonewton per meter squared. 6.3 kilonewton per meter squared. Okay. So now, having that, we're going to talk about our GK. So we'll say, if that is it, now W will now be 1.4, sorry, 1.4 GK, which is 1.4 times, or let me use the proper way, 1.4 brackets 6.30, oh, sorry, 6.30, 1.4 bracket 6.30 plus 1.6 brackets. You know, we are using our imposed load as 1.5 bracket 1.5 bracket 1.5. So when you now calculate this should be giving us equals to 11.22 kilonewton per meter square. Sorry, I made a mistake. Per meter square. So now we have this, having gotten our load. So when we are adding our load, we're adding our W, so W is equals to this. So when we're adding our W, this is what we're going to be getting. But Orion also have a way of generating its own. Orion also have a way of generating its own. So the next thing, probably after this, I can call it a day, is I'm going to assume the self-weight of the floor, of the first floor slab. So if I'm assuming the self-weight of the first floor slab, so having the dimension, if we're having if we're having 225 by 450 of our beam, and if we're having this, so that means I can also go by 0.225 multiplied by 0.450 multiplied by 0.450 multiplied by 24 kilonewton, 24.00. So if that is it, if this is what we are getting, so this should be giving us like around let's calculate it. Let's get our calculator. Okay, so we have 0.225 plus multiplied by 0.450 multiplied by 24 equals, sorry, 0.225 multiplied by 0.450, okay, multiplied by 24 equals to 2.43. So if I'm having 2 points, this will be equals to 2.43. So I'll take it down, say 2.43 multiplied by 1.5. So this now, I'll come back here and say multiplied by 1.5, which is a 1.2 something. And so I'm assuming if you're using a slab load, slab own weight load, it's but we'll get there. Slab own weight, which is, well, what we have here is 1.215. But let's see, having these um, assumptions, let me add the slab. Probably by tomorrow we'll do other ones. So I'm gonna click on slab, click on insert. Sorry, I'm gonna click on slab. Come here, concrete cover. I want to use 25, and the slab height as 150. The load, I'll go back to load. So my dead load. Remember what we calculated. We calculated our dead load as 3.60. So I'll come here, I'll put 3.60. So my imposed load. So I don't even need to type in 1.5. If I right click, you see the imposed load of different structures, residential, communal, and all that. So since it's just normal residential area with limited use or general domestic use, I can use this, and I'll come here, insertion is beam edge. I'll also update, I'll put this. So now I want to cantilever the slab here, but before that, there is no beam here. So you have to be checking your model. So I'll go back, pick beam, and then I'll drop. So I'll come here. So now, practically, if Orion is designing this slab, so you see the part where it says 2 long edge discontinuous or 1 long edge discontinuous. So practically here we have 1 long edge discontinuous and 2 short edges continuous. Do you get it? So this one is just, I will be trying to balance your manual design with Orion so that you will see how it goes. So for now, at this point, at this juncture, let me show you how far, what we've gotten. So if you click on this plan /3D, so you have you see your plan. You see it in 3D format. You see your model in 3D format. So you can right click to hold and rotate your structures. You can right click to hold and rotate your structures. So at this point, I want you to ask your questions, and we'll try to take your questions and see how far. So by tomorrow, we'll complete this structure and we import, we complete this structure. We will not run analysis so that you can balance up with any type of modeling, whether modeling on the inside or importing your architectural drawings. So like I said, if you have a drawing, you can send it. So like here, so this is oblique and perspective view. You want to get an oblique and perspective view. You see the movement. You want to play it as an animation. It will start. You want to record your work. You know, it gives joy. And so you can click on this to start recording. And after recording it to play up in your system. So you can change the way of rotation, and so clockwise and anti-clockwise, that's counterclockwise, anti-clockwise, and you can use flight mode. You see, it's doing like where a flight wants to take off. So it's coming up. So all right, ask your questions. So far, so good. Ask whatever that is your question. Let's see how far. Let's see how far. Let's get reactions. I want to get reactions back from you. I want to get reactions from you. Okay, I want to get reactions. Okay, so in order to make sure we all in order to make sure we all we are all following up, I would like you to try a model. mostly for those that you've done it for a long time. You've done it for a long time. Just try out, model something. I'll post this video this night on the WhatsApp group, the paid WhatsApp group. I'll post this video this night there. Do you get it? So try to model. Send us a screenshot of it on the WhatsApp group. Send us a screenshot of it on the WhatsApp group, and we'll go from there. All right. Okay, I'm still waiting. All right. Since no one is coming up at this point, I'll call it a day. I want to say thank you. Okay, I have a pop-up. Okay. Okay, sir. We'll slow down a bit. It was actually why we have to take it up. It was actually why we have to, bring it down like this. Do you get? So we'll also try to break it down together alongside the game. We'll slow it down. Thank you for that response. We'll slow it down. Any other person? Any other person? Okay. In the absence of any other person's reaction, I would like to call it a day. I would like to say thank you for your patience. Zoom nearly messed up with us today. But I want to say thank you. You guys are the best. Okay, the class tomorrow will start up earlier. It will start up earlier. The class tomorrow will start by 7:30. By 7:30. So if we have those who are working who cannot meet up by 7:30, please let us know. Or we can still keep it at 8 o'clock dot. 8 o'clock dot. We'll re-edit our flags, our online this thing, flags, and we'll post it up. It will start up automatically by 8 o'clock. Nothing will stop that. Nothing will stop that. Okay. So, like I was saying, thank you. I really appreciate your patience. I really appreciate it. I really, really appreciate. And thank you, and God bless you.